Welcome to Communication Engineering playlist. Here in this session, I'll be going to explain modulating index in amplitude modulation. Now see, in previous session, I have already explained you what is amplitude modulation, and based on that we have derived amplitude modulated signal. Now in that amplitude modulated signal, if you have remembered, that derivation was yt is AC sine omega ct plus mu AC by 2 cos of omega c minus omega mt minus mu AC by 2 cos of omega c plus omega mt. So that is what the basic equation which we have derived in last session. Now here mu, that is modulating index, mu, that is modulating index, and that modulating index is amplitude of modulating signal divided by amplitude of carrier signal. So here amplitude of modulating signal, that is AM, and amplitude of carrier signal is AC. So modulating index, that is AM divided by AC. Now as I have told you in last session, like modulating index plays very important role in amplitude modulation. So I have made this separate session for understanding of modulating index. Like see, as I have explained you, if you have input signal like this and carrier signal like this, which is high frequency carrier signal compared to modulating signal, then in amplitude modulation output signal will vary with respect to modulating signal, where amplitude of carrier signal is getting changed. So carrier signal's amplitude, that is getting changed, and if you see that derivation where mu is AM by AC, so as I have told you, mu modulating index, that should be lower than unity, otherwise there is a possibility that we can have phase distortion. So that I'll explain. Like see, here I have modulating signal, and that modulating signal, that is having amplitude varies from plus AM to minus AM, right? So here this amplitude is minus AM. Now if I have modulating index that is lower than 1, it means AM by AC, that is lower than 1. It means AM is lower than AC. So if modulating index that is lower than 1 means modulating signal's amplitude is less than carrier signal's amplitude. So as you can see, this modulated signal, that is having maximum amplitude which is AC plus AM, and minimum amplitude, that is AC minus AM. So here what will happen, this minimum signal, that is AC minus AM, where if AM is less than AC, then you will be finding somewhat envelope is there. So here I have shown you that case where if modulating index that is lower than 1, then you will be finding somewhat signal which is happening at minimum amplitude even. But in case of, if you consider modulating index is equals to 1, means AC is equals to AM. So what happens, over here signal is AC minus AM, and if AC minus AM, that is what AC and AM are similar, in that case AC minus AM will be 0. So you can see if mu is equals to 1 at this instant, over here, modulated signals output is 0. Over here modulated signals output is 0. Now if you consider modulating index that is greater than 1, so if that signal's modulating index that is greater than 1, so in that case here you will be finding distortion is happening. So this is what distortion. So here signal is getting lost, so no information. So here there is no information during this time period here. So that is what the issue which will generate as if you have modulating index that is greater than 1. If modulating index is greater than 1 means AM is greater than AC. So in that case there is a problem of distortion, and where possibility of loss of information is possible. So that is what one issue. Now see, in next session I'll be solving examples based on amplitude modulation. So how many things that you need to keep in your mind? First is this basic equation. It should be clear to all. Like in AM signal there are three frequency component: carrier omega c, lower sideband omega c minus omega m, upper sideband omega c plus omega m. So this is what lower sideband LSB, this is what carrier signal, and this is upper sideband USB. Carrier signal is having amplitude AC, lower sideband is having amplitude mu AC by 2, and upper sideband is having amplitude mu AC by 2. One more thing, modulated signal that varies from maximum to minimum, where maximum is AC plus AM and minimum is AC minus AM. So maximum amplitude, if I say you have A max, so maximum amplitude is AC plus AM, and minimum amplitude, that is AC minus AM. So this many things that you need to keep in your mind to solve problems based on amplitude modulation. So modulating index plays very important role in amplitude modulation, and these are the basic formulas that you need to remember to solve examples based on amplitude modulation, and that is even very important for GATE examination, where there could be a problem based on amplitude modulation. So one should know amplitude modulated signal, that is AC sine omega ct plus mu AC by 2 cos of omega c minus omega m into t plus mu AC by 2 cos of omega c plus omega m t, where here this is what negative sign, but there could be sine or there could be cos. In some books you will be finding equations are there in terms of sine, so you don't need to worry about, you just need to see amplitude of bands. So upper sideband and lower sideband amplitude will be mu AC by 2. So this is what the basic thing that you need to concern about, and frequency of sidebands, that will be omega c plus omega m and omega c minus omega m. And for maximum and minimum amplitude of modulated signal, you should understand it should be AC plus AM for maximum amplitude, and for minimum amplitude that will be AC minus AM. So these many things that you need to understand for modulating index and amplitude modulation. Thank you so much for watching this video. In next session I will be going to explain you examples based on amplitude modulation. Thank you so much for watching this video.